So once again, this video is going to be an explanation of exactly what you're going to see on the test. Of course, not in the same order because quizzes rearranges everything for us. So I could tell you at least this on Chapter 6 test. There will be 5 of these questions, operations with functions. So you might want to jot that down somewhere, 5 questions on operations with functions. And right here, I give you a f of x function and a blue g of x function. Now, what kind of 5 questions could I ask you? Well, I could ask you to do f plus g of x. That's simply telling you to add the f of x function with the g of x function. Or maybe I tell you to do like g minus f of x. That's just saying take your g of x function and then subtract your f of x function from it, which would imply that you need parentheses and distribute that minus sign. Or I could ask you to do something like f divided by g of x. This is all function notation, and you need to know how to do these. Now, division, it's simple. You just place the f of x function, the 2x minus 5, place it over the g of x function, which is x minus 3. And if you leave that as your answer, it's going to be wrong. Because in addition to this answer, you also have to state, let me do this, I want to put, but x cannot be 3. This is part of your answer right here, but x cannot be 3. Why is that? Because if 3 were x, then in the denominator you would get 0, which would make it undefined. We cannot divide by 0. It makes it undefined. So all of these are really simple. That's barely 3, and I'm saying there's 5 questions. So what else could I ask you? I could ask you to do f times g of x. You'd write both binomials and do distributive property and combining like terms. And I could also ask you to do f of g of x. Okay, f of g of x. So I want to open up the floor to you guys. Which one would you like to see? 1 through 5. Do you really want to see adding f plus g of x? Do you really want to be subtracting g minus f of x? I don't know. Or do you want to see number 5, which you plug in one function into the other? Plug in one function into the other. Okay, thank you for asking. I'm going to plug in the blue g of x function into the bigger f of x function, okay? So I'm going to start by writing my bigger f of x function. What is my bigger f of x function? 2x minus 5. Here it is. 2x minus 5. That's my big f of x function. Now, think about it, guys. If I were to say find f of 5, what would you do? You'd plug in 5 right in there. 2 times 5 is 10. 10 minus 5, the answer is 5. Oh, easy. If I say f of 5, you just plug in 5. But right here I'm saying f of g of x. So I'm not plugging in 5, I'm plugging in g of x. This blue function right here is what we're plugging in. The x minus 3, that's the g of x function. That's what I'm plugging in. And what you need to do is just simplify it, right? 2 times x, 2x, 2 times minus 3, minus 6. Bring down the minus 5. Final answer, what is f of g of x? F of g of x is 2x minus 11. Ta-da! You see, it's easy. So expect 5 questions with operations with functions, right? I might ask you to add them, subtract them, multiply them, divide them, or plug in one function into the other. Now, there was also on this section of this chapter finding the inverse functions. And how do we find the function? I hope we remember that. I'm only putting one question of finding the inverse function in our test because, I mean, if you know how to do one, then you know how to do all of them, right? How do we find the inverse function? Does anybody remember?
Set it equal to 0.
That's how to find the, to find a y-intercept. You set the x value equal to 0 or to find the x-intercept. I mean, so if you don't remember, check out what I just drew right there. You have your x's and y's that we need to switch, and then we need to solve for y, okay? In case you forgot, to find the inverse, switch x and y, then solve for y. Okay? Those are your notes. If you know that, you're good. So I'm going to switch. I'm just going to magically switch Instead of y equals, it says x equals. Instead of 7x, it's going to say 7y, and then minus 2 at the very end. So I have switched my x and my y, and now I need to rewrite it in function form, right? I need to get the y by itself. So I need to add 2. You can't really add x plus 2, so I'm just going to rewrite it. X plus 2 equals 7y. I need one more thing to get the y by itself. Have to divide by 7. Divide the whole thing by 7. That cancels out. So my answer is y equals, but instead of writing it on the left side, I'm going to write it on the right side. Y equals x plus 2 over 7. Now that is your inverse function of the original y equals 7x minus 2. However, they might choose, like on the multiple choice, it might not be written like this. They might split the denominator to each of the terms. Now, I don't see, there's no advantage to doing that right now. But if they did, recognize that there's an invisible 1 in front of the x. So it could be rewritten like this. Y equals 1/7 with the x right there plus 2/7. This is also the same exact answer. It's just written differently. Either one of those is fine. There's going to be one question on finding the inverse. All right, so we have operations with functions. We have find the inverse, switch x and y, and solve for y. And then we have a huge chunk of the test, 7 questions. And you know, who knows, maybe I'll chop down the number of questions. I'm going to take it tonight. If I get exhausted, I'll be shortening it. But as of right now, there's 7 questions dealing with graphing radical functions. Okay, so you could jot that down in your notes if you want to get prepared for the test. There's 7 questions so far on graphing radical functions. If I delete any, it's only going to be like 1 or 2, so it's still going to be a huge chunk of the test. One thing that you could write is Desmos. Desmos will help. You could go to desmos.com. You could actually type in functions and see the graph, right? But obviously, if I give you 4 or 5 different graphs and you're trying to plug it in, it could take you a long time to figure out which one's the right one. With Desmos, it's a lot easier if you just understand how these different values affect a parent graph, right? Let's begin by recognizing what the parent graph looks like. Y equals the square root of x. On an xy plane, here's a quick sketch. I already know that the square root of 0 is 0. So 0, 0 is the beginning point. That's the most important point. I also know that the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Those are the coordinates that I get. That's why the parent graph looks like this. It shoots off in one direction. It's not a line, it's a curve. It didn't come out that well. Maybe I should do that a little bit better. It looks like something like that, okay? Anyway, that's the parent graph, and the parent graph will get manipulated by the different values a, h, and k. First of all, we need to remember that hk, the coordinate hk, is the most important coordinate. It's the beginning point. The hk coordinate is the beginning point, and it'll shoot off in one direction from that value. Always remember to think opposite on h, and then take k for what it is. There is a minus sign in front of h, so whatever you see here, if it says x plus 5, remember that h is a minus 5. If it says x minus 1, remember that h is plus 1. Think opposite on h, take k for what it is, and that'll give you that beginning point. H will always be inside parentheses or square roots with the x being subtracted from x, which means think opposite. The k value will always be on the outside by itself. The h will always be the left and right shift. The k will always be the up and down shift. The a value tells you if it gets reflected. It tells you if it's reflected, if the a value is negative. If it's not negative, it doesn't get reflected over the x-axis. What else does it tell you? It tells you if it's vertically stretched. That's if a is greater than 1, or vertically compressed if it's a value that's between 0 and 1, a value that's like a fraction or a decimal between 0 and 1. Okay? So all of these things are very important, and they will help you immediately find answers, right? There's also going to be some true and false questions, like select all the true statements. You need to know this knowledge in order to be able to answer those questions. Again, this so far looks like the biggest part of the test on Chapter 6. So please review, I don't know, go back to the previous weeks to watch those videos if you still don't get it. There will be, I think, one question where knowing these things, it'll become really easy. Like, let's say I give you one that's like this, say that black graph, and I give you 5 different radical equations, radical functions, and I tell you which one it is. And you could eliminate the ones that have the a value of -1 because it didn't get reflected over the x-axis. You could look and see, oh, the h value, 1, 2, 3, so it should be a +3 because we went in the negative direction. You think opposite. You'll be able to identify it, but there's going to be, it looks like it's vertically stretched, and there's going to be one that has a vertical stretch of 2 and a vertical stretch of 3. So you're not going to be able to identify just by looking at it. You're actually going to have to pick a nice point on the graph to be able to plug in the x value of that coordinate and see if it gives you the y value of that coordinate. Okay? If you have no idea what I'm talking about, go ahead and graph them on Desmos. It'll take you a little bit longer, but you'll be able to identify the correct answer there. But what I'm saying is, like, let's say I gave you this graph, this square root function. It's in black right there. And let's say you narrowed it down to option A, which was y is equal to, let's say, 2 square root of x plus 2 plus 1. Or let's say option D, which was y equals 3 square root of x plus 2 plus 1. So the h and k are both the same, and they both look appropriate, 2 up to the left and 1 up. So both options look good. The only difference is one is a vertical stretch of 2, one's a vertical stretch of 3, and you can't visually see the difference between the vertical stretch of 2 or 3. So I would pick any coordinate. So like if you pick a coordinate right here that's at, let's say, -1, +5, -1, +5. Like, I'm just making this up, guys. But you plug in the -1 for the x, plug in the 5 for the y, and see if it gives you a true statement. You'll be able to identify it that way. But then again, if you don't feel like doing that math, you could use Desmos, type in both of those, see which one gives you the accurate graph. All right, that's enough time on this section, even though it's a pretty big section. It's already been 6.5 minutes. Let's move on. There's going to be 4 questions on simplifying radicals, right? Square roots, cube roots, and they could even be written as the power of 1/2, power of 1/3, power of 1/4, right? Now we need to remember that we could split a root to each of the terms when there's pure multiplication on the inside. So we're going to split all this up. Let me show you. Okay, and we need to remember that the square root of 81, well, that's a perfect square number. It works out beautifully. We want a perfect square number. So just for kicks here, if this were not a perfect square number, what I would do is I would rewrite it with multiplication to get a perfect square number. Again, if I don't have something that I want, I would rewrite it with multiplication to get something that I want, okay? So the square root of 81, luckily it's a perfect square number. That the answer becomes 9. I'm going to write a big 9 down here. That's going to be a part of my final answer, right? So there we go. We got 9 right there. The square root of 81 is 9. Now, x, the square root of x to the 25th power. See, this is one fact that we need to remember, that a square root is really the power of 1/2. Same thing with cube roots, right? A cube root is really the power of 1/3. Okay, so if I were to rewrite this as x to the 25th to the power of 1/2, then I know that a power to a power I need to multiply. It's really 25 times half, which is really 25 divided by 2. And that's kind of not cool because you can't divide 25 by 2. You end up with 12.5, which could be done, right? You could do 12.5 and then split it. But how about this? Since we know that we could rewrite things with multiplication. You see, I would want this 25 to be something divisible by 2 since I'm multiplying it by half. So what I'm going to do is I'm going to rewrite this radical function. I'm going to rewrite the radical as the square root of x to the 24th times 1 more x. And then I'm going to split the root. I'm going to split the root. And now I could divide 24 by 2, giving me the answer x to the 12th, and then the square root of x will stay right there. Okay, let's move on to the next one, the square root of y to the 36. That is divisible by 2. I could rewrite it like this with the parenthesis to the power of 1/2. I could say y to the 36 to the power of 1/2. I already know it's 36 divided by 2, which is 18. So I will end up with y to the 18th power. Okay, no square root. Finally, the square root of z to the 9th. That's not a value divisible by 2. The power is not divisible by 2. So I'm going to rewrite that as z to the 8th times 1 more z. That way I could split the root, and that 8 could be now divisible by 2. So that'll become z to the 4th square root of z. All right? So what do we have as our answer so far? We have 9, and then we have this answer, and then we have y to the 18th, and then we have z to the 4th square root of z. So let's put all of our outside values, the 9, you know what, let me do this in black. The 9, the x to the 12th, bring it down, the y to the 18th, bring it down, and the z to the 4th, bring it down. And then let's bring down everything inside the square root. What do we have inside the square root? We have the square root of x, and we also have the square root of z. So let's put both of those x and z together underneath one square root. So here's your final answer, believe it or not. 9 x to the 12th, y to the 18th, z to the 4th, square root of x, z. I know what you're thinking. Man, this is fun. I can't believe this is free, right? Free admission, guys. Free entertainment. Who needs to party? Nobody, right? You got a party right here. Okay. I'm telling you, back when I was in high school, I would show up to a house party, turn on the lights, turn off the music, tell everybody to gather around. I explain to them how to simplify radical expressions. Pfft, instant popularity. Yeah. You don't believe me, huh? All right. Let's try the third root right there. So again, we're going to split that third root to each of the terms. And then we're going to work on them one at a time, right? The third root of 54, I need a perfect cube number. I wish it could be an 8. I wish that 54 was a 64. Then it would be the answer 4. But it's not. So I need to rewrite it with multiplication to get a perfect cube number, right? By the way, some calculators do this for you. So the cube root of 54, I want to break it down multiplication to get a perfect cube number like 27. You see, 3 times 3 times 3 is 27. 27 is a perfect cube number. 27 times 2 will give me 54. So if I split that third root to both of those, I will get 3 cube root of 2. And now for this one, we need to remember that it's always a radical changed to a rational exponent. It's always going to be power over root. X to the 12th divided by 3. So a fraction that's an exponent, 12 divided by 3. What is 12 divided by 3? It's 4. So your answer will be x to the 4th. I didn't show my work there. Maybe I should have. But I hope we remember power over root. 12 divided by 3 is the power of 4. Last but not least, going for our last one right there, I'm going to rewrite this. Remember, guys, the third root is really the power of 1/3. I want this power to be divisible by 3. Kind of like 12 was divisible by 3. I want 4 to be divisible by 3, but it's not. So what I'm going to do is I'm going to rewrite it with multiplication. I'm going to write it as y to the 3rd times 1 more y. And then I'm going to split the third root right there and the third root right there. And we know that this guy right here ends up just being y. and then the third root of y comes down. So I have all these different answers, and I need to organize those answers and put them together. I want to keep the radicals together underneath one single radical, and everything that's outside of the radical outside in the front. So let's do that. The first part of my answer will be 3. Second part, x to the fourth, y. Again, 3, x to the fourth, y. And now we're going to put the third roots, and we're going to put the 2 right in there, and we're going to put the y also right in there, and we are done. 3x to the fourth y, third root of 2y. Fun stuff, I know. Okay, so at the end of it all, there's only 4 of those questions. It is significant. There's going to be 5 questions on solving radical inequalities, square roots, third roots, and they might be written as rational exponents, right? The power of 1/3 is really the third root. So I hope you remember step 1 of solving any radical or rational exponent equation is to isolate the radical or the rational exponent term. So on number 1 right here on the first example, I'm going to add 1. It's going to cancel, add 1. I'll get -2 square root of x equals 16. Then I divide by -2, divide by -2. I will get square root of x equaling -8. Now at this point, I could stop right there because I know that a square root will not produce a negative answer. Now a cube root, you could do the cube root of -27, that'll give you -3, but you cannot do the square root of 16 to give you the square root of 64 to give you -8. You can't even do the square root of -64 to give you -8. It doesn't work. So right there I could stop and say no solution. No solution. Now let's say you didn't recognize that. Okay, let's say you kept going. Go for it, no problem. Square it to get rid of the square. Square it, you'll get x equals +64. And you're thinking, yeah, that's my answer. And it will be on there on the multiple choice. And if you put it there, it's going to be wrong. Why? Because you're forgetting the last step on solving. Once you get an answer, you should always double check and verify it. Now check this out. I'm going to take the 64 and put it right there. The square root of 64 is 8. -2 times 8 is -16. -16 minus 1 is -17. That's not a -17. That says +15. This is wrong. 64 did not work. That's what we call an extraneous solution. So we need to conclude that there is no solution. Okay? Once again, if I'm going a little too fast, it's because we're running out of time, and this will be available to you later on video. You could go back, watch it again. You could slow it down. You could pause it. Let's do number 2 right here. We want to isolate that third root, right? The power of 1/3. How do we isolate? We're going to get rid of the multiplication of 4 by dividing by 4. Dividing by 4, you will get x minus 17 to the 1/3 power equals 3. How do we get rid of the 1/3 power? Anybody? Thank you, power 3. Power 3, okay. So we end up with x minus 17 equals 27. And of course, let's continue solving. X equals, that becomes 54, I believe. I believe I could fly. Okay, so if x equals 54, double check it, plug in 54. 54 take away 17. What is that? 27. The third root of 27 is 3. 4 times 3 really is 12. It does work. You know you're right. So there's 5 questions on solving radical equations. Make sure you double check, because if it doesn't work, it's an extraneous solution. Now for the final part of the test, there's going to be 3 questions on solving radical inequalities. It's almost like solving radical equations. There's just an extra 2 steps, right? What are the extra 2 steps? Well, you first need to begin. Well, you don't actually need to begin, but I on the notes, I say begin with the radicand value and setting that to be greater than or equal to 0. Because you don't want this to be a negative number, because if it's negative, then the whole thing becomes imaginary. It doesn't work. So let's begin by setting 3x plus 3 to be greater than or equal to 0. Subtract 3, 3x is greater than or equal to -3. And then divide by 3, x has to be greater than or equal to -1. So that's one possible answer right there. Okay. That's step 1, setting the radicand value to be greater than or equal to 0. Step 2 is to go back to the original and solve the whole thing kind of like if it were an equation, all right? So let's get rid of the minus 2 by adding 2. Let me rewrite what I have. I have the square root of 3x plus 3 is less than 9. Oh yeah, by the way, guys, be careful on these inequalities. If you ever multiply or divide by a negative, you will have to flip the inequality symbol. Let me repeat that. Let me even be more specific. On one of the questions on the test tomorrow, you will end up multiplying or dividing by a negative. Right here, I added 2. But like, what if there would have been a times negative 2 right here? I'd have to divide by negative 2, and that would have to flip the inequality symbol. So I'm telling you right now, there will be one question where you have to actually multiply or divide by a negative, which will cause the inequality to flip. Okay, so beware of that. Right here, it does not flip. Anyways, let's continue solving. We're going to get rid of the square root by squaring it. By squaring it, we end up with 3x. Let me put a line here so we don't get confused. 3x plus 3 is less than 81. Continue solving. Subtract 3. We end up with 3x is less than, what is that, 78? And then finally, last step, divide by 3. That is, x is less than, if you use a calculator, I believe it's 26. X is less than 26. Is it? Let me double check. 78 divided by 3. Yep, 26. Dang, I amaze myself sometimes. Anyway, we have those two answers. So we now need to do step 3. Ladies and gentlemen, step 3 is to go back and plot these answers on a number line, and you can either double check them with algebra or understand the representation visually. So here's my number line. Here is the number -1. Here's the number 0. Over here is the number 26. So let's do this one in red. It says x is greater than or equal to -1, solid dot, greater than is that way. Let's do this one in blue. X is less than 26, open dot, less than is that way. Where's the overlap piece? The overlap piece is in between the two. So I already know that my answer will be -1 is less than x is less than 26, a compound inequality, but don't forget that the first one was a solid dot, so that should be a solid line underneath that inequality, and here is my answer. -1 is less than, x is less than 26. That was question number 19 from WSPM, and there's my answer just to verify. Okay? Anywho, we also have this guy, another one. Let's do step 1, which is setting the radicand to be greater than or equal to 0, because if it's negative, it'll be imaginary. So we're going to have 4r minus 3 being greater than or equal to 0. And when you solve that, plus 3 cancels plus 3. You're going to end up with 4r is greater than or equal to 3. Divide by 4. You're going to end up with r greater than or equal to 3/4. That's one possible answer. The other answer is to go back and solve the original as if it were an equation. So you will get rid of the multiplication of 2 by dividing by 2. And remember, tomorrow might be a -2 right there, which would cause the inequality to flip. But in this case, it's not a -2, it's a +2. So what do I have left? I have the square root of 4r minus 3 is greater than, it did not flip, 5. Okay, on tomorrow, you might have a -2, which will cause that inequality to flip. So now we're going to square both sides to get rid of the square root. We will end up with 4r minus 3 is greater than 25. Add 3 to both sides, plus 3. We end up with 4r is greater than 28. Divide by 4. We get the final answer, r is greater than 7. So now we need to go to a number line, ladies and gentlemen. Number line, here is the value 3/4. It's not quite 1, but it is greater than 0. And then we have the value of 7 over here. So let's go to the first one in blue. X is greater than or equal to 3/4. Solid dot at 3/4, greater than is to the right. R is greater than 7. Open dot at 7, greater than is to the right as well. So as you can see visually, the areas don't overlap in between the two values. They overlap at the 7 and to the right. Okay, so if I were to extend this blue line going this way, where's the overlap piece? It's from here at 7 going that way. So that means that the inequality is just r is greater than 7. You do not write it as a compound inequality. Okay, on both of these, I apologize, on both of these, I've been concluding my answers visually, but you don't have to conclude them visually. You could actually plug in values. Like if you wanted to, you could plug in the number 0. It will not work. 0 times 4 is 0, minus 3 is negative 3. The square root of a negative is imaginary, so that one doesn't work. If you plug in a number in here, it's not going to work either. Like let's say you plugged in the number 1, which is a little bit bigger than 3/4. 4 times 1 is 4, minus 3 is 1. The square root of 1 is 1. 1 times 2 is 2. 2 is not greater than 10, so in the middle it doesn't work. Now you can plug in any number you want over here that's on the right side, like 100. 4 times 100 is 400. 397, the square root of that is a huge number. Multiply it by 2, it's going to be huge, and it will be greater than 10. So you could also do it algebraically. You don't have to do it visually. It's totally up to you guys. Ladies and gentlemen, it's been a long lesson. It's been a long video. I'm done. Hopefully you guys all study and get an A+ on tomorrow's test.